So let's write the equation of each conic section. The first one is a parabola. And since it's a parabola, we need the vertex and we need the a value. And the vertex, since this parabola has a directrix that's x equals 4, it means it's a horizontal parabola. And since I know it's horizontal, it means that the -1 is going to remain the same for my focus and my vertex. So I know the -1. The vertex is halfway between the focus and the directrix. So if I've got a 6 and a 4 halfway between that, I can use my midpoint formula, 6 plus 4 divided by 2, which is going to be 10 divided by 2, which is 5. So that's going to be a 5. And now the a value, the directrix, the formula for the directrix is x equals h minus 1 over 4a. I know x for the directrix is going to equal a 4. I know h is 5. And now I just have to solve for a. So I'm going to subtract the 5 from each side. And that's going to give me a -1 equals a -1 over 4a. If I rewrite that over here, let's see. -1 equals... I apologize, my board is being a little bit glitchy today. It's having a little bit of trouble. So now I've got to multiply each side of this equation by a 4a. I'm multiplying through to get rid of the denominator. See over here it's going to cancel. Over here I've got a -4a. Over here I've got a -1 left. And now I've got to divide each side by a -4. Which leaves me with an a equals a positive 1/4, negative divided by negative. So that's a 1/4. So now my equation, since it's a horizontal parabola, is going to be x equals 1/4 and then y minus k, which is like the +1, squared minus h, which is the 5. And that's it. For this one, we're talking about a circle with endpoints of the diameter at 0, 3, and 6, -5. So I need the center, and I need the radius. For the center of this guy, I'm just going to do my midpoint formula. I'm going to find the midpoint between these two. So for the x values, that's going to be x1 plus x2 divided by 2, so 0 plus 6 divided by 2. I add the y values together and divide by 2. So this is going to be 6 over 2. This is going to be a -2 over 2. So that's going to be a 3 and a -1. So my center is 3, -1. The radius is the distance from the center to one of the outside points. So I'm just going to take my distance formula. I'm going to use one of these points. I'm going to use this point. So I subtract the x values. So I've got 3 minus 0. Again, I'm using my center and my endpoint. So 3 minus 0 squared plus subtract the y values. That's a -1 minus 3 squared. So that's the square root of 9. I don't know why I have a comma over here. Plus -1 minus 3 is a -4. -4 squared is 16. So that's the square root of 25. So the radius is 5. Now I'm going to plug this into my standard form. So that's x minus h squared plus y minus k squared equals r squared, which would then be the 25. Okay? Easy enough? If I look at the next one, it says the ellipse with endpoints of the major axis at 6, 10 and 6, -4, and then the foci at 6, -2 and 6, 8. For an ellipse, I need the center, I need the a value, and I need the b value. The center, if I look right here, I see the repeated value of 6, and I could use my midpoint formula, but the 6 is obvious enough. Between the 10 and the 4, I need the midpoint between those, so I'm just going to use half of my midpoint formula, so 10 plus the -4 divided by 2, so that's 6 over 2, which is 3. So the center is 6, 3. For the a value, I need the distance, and I could use my distance formula. However, with these, there's a shortcut. Since the sixes are the same, I just need the distance between 10 and -4. So I can just count. If I counted from -4 all the way up to 10, it would be 14 spaces. So the major axis is 14 units long, which means my A value is half of that. It's 7. Okay. I do the same thing with the foci. If I look at the distance between these two, since the sixes are the same, the distance from a -2 to a +8 is 10 units. And since that's 10 units, half of that would be 5, but that's not my B value. Okay, that's actually my C value. Remember, the major axis gives us A, the minor axis gives us B, the foci give us C. And now I've got that fancy little equation, C squared equals A squared minus B squared. So I've got 25 equals 49 minus B squared, and I've got to solve for B. So I'm going to subtract the 49 from each side. I'll bring that up here. So I've got a -24 equals negative B squared. I got to divide each side by the -1. So I find out that B squared equals 24. Now I've got to take the square root of each side. And when I do that, I find out that B equals the square root of 24. And I'm going to leave it as just the square root of 24. I'm not going to simplify it or change it. Because now when I plug this into my standard form, remember the standard form for an ellipse, since this one, I have to decide if it's vertical or horizontal. If I think about where these points are located for the major axis, 610 would be up here somewhere. 6 -4 would be down here, so I know this is vertical because my major axis runs up and down. So I'm going to do y minus k squared over A squared. Well, A squared is the 49 because it's 7 squared. Plus x minus h squared over B squared. Well, if I take the square root of 24 and square it, I'm left with a 24. And it's always equal to 1. And that's the equation of my ellipse. If I take a look at the next one, we're looking at a hyperbola this time. And hyperbola is very similar to what we did with our ellipse. I still need the center, the A value, and the B value. The center, again, is going to be the midpoint between these two. So if I'm looking for the midpoint, right away I can see the 1 is repeated. So then between 11 and 5, I'm going to use a piece of my midpoint formula, 11 plus the -5 divided by 2. And that's going to give me a 6 divided by 2, which is 3. There's been a lot of that going around. And now for the A value deals with my transverse axis, which is between the vertices. So the distance between these two is a 16 units. So half of that would be 8. So that's my A value. And then it says that the length of the conjugate axis is 10. Well, if the conjugate axis is 10, it means the B value is 5. Now I've got everything I need. I've just got to decide if this is vertical or horizontal. So again, I think about it the way it looks on the graph. 11,1 would be up here somewhere. -5, 1 would be up here, which means my vertices and my transverse axis are running horizontally. So this is going to be a horizontal. So it's going to be x minus h squared over A squared, which is the 64, minus y minus k squared over B squared, which is the 25, equals 1. Okay? For this last section, we just have to determine what kind of conic section it is. And remember, we have those 3 questions. The parabola is the obvious one. It's only got one quadratic term. The circle, the 2 quadratic terms will have the same coefficient. The ellipse, the coefficients of the quadratic terms will be different but have the same sign. And the hyperbola, the quadratic terms will have different coefficients with different signs. Okay, so if we look at this one, does it have more than one? Does it have only one quadratic term? No, it's got 2 quadratic terms. It's got an x squared and a y squared. Are the coefficients the same? The 3 and the -8? No, so it's not a circle. Do they have the same sign? No, so it's not ellipse. One's positive, one's negative. So that means this one's going to be a hyperbola. Okay? For the next one, does it have only one quadratic term? No, it's got two quadratic terms. It's got an x squared and a y squared. Are the coefficients the same? Well, this is a 1 and this is a 3, so no, so it's not a circle. Do the coefficients have the same sign? Yes, they're both positive. It's a positive 1 and a positive 3, so it's an ellipse. For the next one, is there only one quadratic term? No, there's two. There's an x squared and a y squared. Are the coefficients of the quadratic terms the same? Yes, it's a 4 and a 4, which means it's a circle. And then this last one, is there only one quadratic term? Yes, there's only one quadratic term, it's an x squared, which means this has to be a parabola. All right, and that's it. That's all there is to it. Hopefully this was helpful, and good luck on your test.